Okay, part 2 of the notes for sections 3 and 4. Using our formulas then, if the sine of theta equals y over r, then we can see that we solve that for y and we get y equals r sine theta from the last slide. So we want to find the sine of 90 degrees. Well, the ordered pair at 90 degrees is 0, 1. The radius of the circle is still 1. So the sine, if we're on a unit circle of a radius of 1, remember that this formula then would, the r would be 1, so the sine of theta would equal your y coordinate. So when you're working on a unit circle, the y coordinate is the sine, so the sine of 90 degrees is 1. The cosine is the x coordinate, so the cosine of pi, the x coordinate here is -1. All right, now the trig functions of special angles. What you have to do is be able to find the 6 trig functions for your special angles. The special angles are the ones on the unit circle that we've been working with. With the 45-45 right triangle, like we did in our activity, we have the root 2 over 2 and the root 2 over 2. With the 30-60-90 triangles, where the radius is 1, or the hypotenuse is 1, the long side is root 3 over 2, and the short side is 1/2. Short side 1/2, long side root 3 over 2. So the tangent then, let's look at the tangent of 30. The tangent of 30 would be opposite over adjacent, so that would be 1/2 divided by root 3 over 2. If you reduce, you get 1 over root 3. Multiply numerator and denominator by root 3, and you end up with root 3 over 3 for the tangent of 30 degrees. You need to fill in your tangents on your unit circles by dividing the y divided by the x, or the, if you're looking at the angle, the opposite divided by the adjacent, using SOHCAHTOA. So now knowing that, I need to find my special values here. So 240, I think about 240, and it's here, so that behaves the same way as a 60-degree angle. So this is the short side, this is the long side. So the tangent of 240 is opposite over adjacent, which would be root 3 over 2 over 1/2. These reduce and leave us with root 3. The sine of 2 pi thirds, so pi thirds, 2 pi thirds, is the same as the pi thirds over here. The sine of pi thirds is your y coordinate, so short side 1/2, long side root 3 over 2. So the sine of 2 pi thirds is root 3 over 2. The secant of 3 pi fourths. So this is 1 pi fourths, 2 pi fourths, 3 pi fourths. And that relates to just pi fourths, so this would be root 2 over 2, root 2 over 2, and 1. So the secant, if you go back and look at your definitions, would be r over x, or you can just think of it as the reciprocal of the cosine. So the cosine is adjacent over hypotenuse, so that would be root 2 over 2 over 1. So the reciprocal of that would be 2 over root 2 for the secant. But that's going to the left, so it'd be negative. And then we would want to take that 2 over root 2 times numerator and denominator by root 2, and we would end up with negative root 2 over 2. no, we would end up with negative root 2, sorry. Let's try that again. Negative 2 root 2 over 2. The 2's reduce, and you get negative root 2. So we want to find each value using a calculator. Now this is important. If you are in, if it's a degree, you have to have your calculator in degrees. If it's in radians, you have to have your calculator in radians. So you set your mode on your calculator. I'm going to set mine to radians and do all the radian answers first, and then set it to degrees and do the degree answers. So cosecant of 3 pi sevenths. To get the cosecant, you do 1 divided by the sine of 3 pi sevenths. So I would type that into my calculator, 1 divided by the sine, parentheses, 3 times pi divided by 7, close the parentheses, and you get 1.0257. To do the sine of 12, that's radians, just do sine 12, and you get negative 0.5366 if you round it off. To do the tangent of 12, just do tangent 12. You get negative 0.6359 if you round it off. The cotangent of 3 pi sevenths is 1 divided by the tangent of 3 pi sevenths. So you would type that in, 1 divided by tangent, parentheses, 3 times pi divided by 7, close your parentheses, and you get 0.2282. And then to do the degree answers, you change your mode back to degrees. Here we have 48 degrees, 30 minutes, 12 seconds, so we just have to get that into just a decimal. So we would go 48 plus 30 divided by 60 plus 12 divided by 3600, and we get 48.503. So we want the secant of 48.503 degrees. The secant is 1 divided by the cosine of 48.503. So 1 divided by the cosine of 48.503, close your parentheses, and you get 1.509. The cosine of 24 degrees 3 minutes. First, you need to get the 24 degrees 3 minutes, so you do 24 plus 3 divided by 60. So that was 24 plus 3 over 60, and you get 24.05. So then I would just do the cosine of 24.05. So cosine of 24.05, and you get 0.9132.